everyone, welcome to an academy. Myself Deepak Krishna VM, ME Structural Engineering AMI. I'm a verified educator. So today we are going to see a universally accepted test to measure the workability of concrete, the slump cone test. So in this lesson we are going to see how it is done, what are the basic points and what are the inference that we get from the slump cone test. But before that, please don't forget to subscribe to the YouTube channel of an academy and also follow us through the app and the website. So let's see some workability. Hello everyone, good to see you. Hope you're having a great day. So this is another lesson in the basic test for the fresh concrete series. All right. So in the previous lesson we have seen how the bleeding can be calculated or how bleeding can be identified using a test for bleeding in fresh concrete. All right. So likewise, in today we are back with another lesson, which is one of the most important lab tests in the fresh concrete. All right. So this test that has been accepted universally as one of the best tests for the measurement of workability of concrete. All right. So without further ado, let me introduce to you the slump cone test. All right. So let's have some basic facts before we dive into the test. So first and foremost, let's see what are the definition for the workability of concrete. All right. So we are going to measure the workability. So it's very good to know about the workability prior hand before doing the test. All right. Now we have two definitions over here. First one is by ASTM C 12593. The property determining the effort required to manipulate a freshly mixed quantity of concrete with minimum loss of homogeneity. All right. The second one says that the property of freshly mixed concrete, which determines the ease and homogeneity with which it can be mixed, placed, consolidated, and finished. And this is from ACI 116R90, ACI 1990. All right. So both the definition states that this is workability is a property that determines how ease with which we can work the concrete. All right. How easily we can transport, how easily we can mix, transport, place, and compact the concrete. So that's what workability is all about. Now let's move on to some of the other points. Okay, so here we are going to do a standard laboratory test, okay, which is some of the universally accepted. So it has to be followed by some specific guidelines provided by a recognized institution. Okay, so here we follow the code book provided by Indian Standards, that is the IS 1199 1959. It's a very fancy number, 1199. I hope it's easy to remember for you. And also in the USA, the code book they follow is ASTM-C 143. All right. And the Europe, there is another code book. And so what the result we get from this experiment, or the result that we obtained from this test, is the slump value. Okay. And that too in millimeters. All right. So this is a Viva question for you. These three. Okay. It will be definitely asked. And so as I said before, this is most important test to measure the workability of concrete, all right, and which is which is one of the most universally accepted tests for the fresh concrete, all right. And since because of its low maintenance and low cost, and because of its immediate results, this test has been in implementation since 1922, all right. So the entire concrete industry or entire civil engineering world has been using this test since 1922. So please have that respect for this test. All right. Now let's move on to the laboratory experiments or the equipments that we need. Okay. So let's see what are the equipments required. So first and the apparatus. First and foremost, one is slump cone mold. All right. So which has the outer diameter of, So first we have the slump cone mold. We have the tamping rod, a non-porous base plate, and a steel roller. All right. So slump cone mold is a mold which is in the form of a cone, which has a frustum on top. That means the cone will not be complete. There will be a small cutting on the top. That means there will be a small opening on the top of the cone. So the base diameter of the cone will be 20 centimeter. Top diameter will be 10 centimeter. And the total height of the cone will be 30 centimeter. All right. So next we have the tamping rod, which has a diameter of 16 mm and length of 60 centimeters. Okay. And also we have non-porous base plate, which acts as a base for the experiment, and also we have a steel ruler to find the slump value. Okay, now let's see this photograph. All right, so this photograph shows the slump cone test equipments. The equipments that are mainly required for this experiment. That is, we have two slump cones here, and we have a base plate. Okay, so this cone, this is the frustum cone. Okay, that is the top is open here and has a bottom. All right. So, and also this is also a base plate and is kept on a highly non-porous base tray. All right. So the base diameter will be somewhere around 20 centimeters, and this top diameter will be in 10 centimeters. All right, and the total height of this cone will be around 30 centimeters. Okay, and here we have the base plate. It has base plate right here, and it has a base tray right here. Okay. Now let's move on to the procedure. All right, this is actually a very simple one. This can be done both in the labs and in the site. Okay, and also it's very easy to do. It's very low maintenance and low cost. So because of all these advantages, this is one of the mostly accepted tests in the world. Okay, so let's see what are the procedure for the test are. Pardon me. First and foremost, we have to clean the internal surface of the mold and apply oil to it. All right. So the internal surface of the mold has to be cleaned thoroughly so that there's no particles of the previous experiment done. And also we must apply oil in it so that the concrete will slip down easily, or we can easily remove the mold from the concrete mix. All right. Now next is the first, okay, we have cleaned the mold, we have oiled the mold inside, and now place the mold on the base plate, lock it. Okay. Now fill the mold with concrete, okay, layer by layer. Okay, so approximately by 4 layers. All right. So each layer will be having almost approximately equal length or equal height, whatever it is. All right. So fill the concrete mold with 4 approximately equal layers. All right. So by filling equal layers, each layer must be provided with 25 strokes of compaction. All right. So each layer has to be compacted by using the tamping rod by providing 25 strokes. Okay. So each stroke on the if we placed a layer, we stroked it, and we compacted it. Okay. Now another layer came over the previous layer. So while compacting, the rod has to penetrate through the fresh layer to the layer behind it. All right. So the tamping rod has to go through the entire layers. Okay, so that's how you have to get the stroking or provide the compaction. All right. Now remove the excess concrete on the top and level the top. Okay, clean the top and level the top. Now so there will be sometimes there will be mortar or maybe water that is leaking through the gap between the mold and the base plate. So clean that thing also. Okay. Now we are ready for the experiment. Now raise the mold from the setup immediately and slowly. Okay, the mold alone has to come up. All right, and remove it completely. So we have a slump over there. We have a lump of concrete mix over there. All right. So now measure the difference between the height of the mold. Okay, top height of the mold, that first height of the mold, and the top height of the concrete mix. All right. So that height difference, what we get is the slump value. Okay. Now let's move on to the inferences, or what we see from the slump cone test. Okay. So as of from lot of trial and error methods, they have concluded that there will be almost 4 types of slumps that can be formed. Okay. First one is a true slump. Second is a zero slump. We have a collapse slump and a shear slump. Okay. First and foremost, we will try with a true slump. Okay, the true slump will be something like this. Okay, it won't be falling away completely, but the slump will look something like this. Okay, so this dotted lines are the base plate. Okay, now this is the slump. Okay, so true slumps look something like this, and this is the desired slump for the concrete. All right, so this is the type of slump we need to obtain while we do a slump cone test. If the concrete need to be perfect for the construction or perfect for the use, whatever use you're going to do. Okay. So this is the only slump that can be measured in the test. Okay, so only when the true slump is obtained, we must measure the slump. All right. So as I mentioned before, the measurement will be taken from the top of the cone right here and the top of the slump right here, and we must take this difference. Okay, so that height difference is the slump value. Okay. Now the next type of slump is the zero slump. Okay, that means that it will be in the as shape of that cone. Okay, it will be too tight. So this type of slump indicates that the concrete mix has the low water cement ratio. It results in a very dry mix. Okay, so these type of concretes are usually used in the road constructions. All right. So the next one is a collapse slump. This is one of the most undesirable slumps we can ever get. So this shows that its water cement ratio is too high. Okay, or the concrete mix is too wet. So it has very high workability, for which the slump cone test is not probable. For this type of slump or this type of concrete mix which is highly workable and which has very high water content, the slump cone test is not for this. Okay. And next one is a shear slump. So shear slump, something look like this. See the shape? It's quite sheared away. Okay, so this indicates a result in incomplete. Okay, that means the mixing is not complete and the mixture is not in a complete form, and hence the concrete has to be retested again by providing the required adjustments. All right. Set now, when the shear slump is obtained, the concrete mix is not desirable. It has to be retested by providing it adequate adjustments. Okay, so what are the remedies for it? So the first one, we must adjust the mix proportions in the concrete content. Okay, and also sometimes the size, the properties, and the types of various types of aggregates inside the concrete mix can also affect these kind of slump tests. All right, and also sometimes if the cement content is low, also the shear slump can be obtained. All right. So these are some of the small remedies that we can do when there is a huge amount of variations in the slump value. So this is the slump cone test. Okay, so I hope you understand how the test is done. Test is very simply, we have to clean the mold inside. We have to put the oil inside, fill the mold layer by layer. So, okay, each layer approximately of same length. Now compact it provide the compaction for each layer by 25 strokes with the help of tamping rod. Okay, the tamping rod has to go deep. It has to touch the base. All right. Now once the compaction is over, level the top, clean the top, and also level the bottom face where there is a gap between the cone and the base plate. Now remove the cone slowly and immediately. Hence we got the required slump, and compare the slump with the inferences and obtain whatever result we need. Okay, and finally we get the slump value in millimeters. All right, so that's all for today. This is a very simple experiment, but very, very important experiment. Okay, so thank you for listening. Please comment your suggestion, please rate my presentation, and please recommend and share the slides. This is my link to the Profile Driven Academy platform. You can see all the other works that I've done based on the ingredients of the concrete as well as the cement. Okay, so that's all for today. I'll see you with the next experiment in the series. Ciao. Wish you a good day.